Hello, everybody. Welcome to Mo's Lunch and Learn. We're going to cover simple and magical ways to optimize your DynamoDB tables. A little bit about us. My name is Khawaja. You can find me on Twitter. I used to work at NASA Jet Propulsion Laboratory, where I was one of the earliest customers to take AWS into production. That started in around 2008, back when there was only SQS, S3, and EC2. And I joined Amazon Web Services back in 2013 and recently left to co-found Momento with my co-founder, Daniela. At Amazon, I used to run DynamoDB.
All right. Hey, everybody. Pete Naylor. I spent far too many years looking after traditional infrastructure in tier one network providers using their own data centers. About 6 years ago, or actually 7 years ago now, I joined AWS, and I was a TAM, so I was supporting, actually my customer was the internal retail teams and helping them migrate off of Oracle and onto DynamoDB, Aurora, and Redshift. Then I became a DynamoDB solutions architect, a specialist, because I love DynamoDB so much. I saw the impact that it could make. That truly serverless experience was just amazing to witness across all those teams. The time they got back was phenomenal. And then I closed out my time at AWS about a year ago as a DynamoDB product manager. I was in that role for about 18 months. Now I'm at Momento. I'm really enjoying working with the small team and trying to make a bigger impact around the area of caching and pub sub and some other areas that I think should be serverless, truly serverless. By the way, nice shirt, Khawaja. I like that one.
Thanks, Pete. You
we
too.
got our DBCon uniforms on.
And we got a call out to Ellery, who's at GopherCon today, presenting with the same shirts.
I actually got to sit in in what we call the war rooms for events like Prime Day and Cyber Monday, Black Friday, with these retail teams as they had just migrated to DynamoDB. So there was a lot of learning going on at that time, both in how to data model effectively and make that transition, but also in how to operate DynamoDB well, how to understand the partitioning and figure all this stuff out. So over those years, I saw these teams move from a situation where they were spending, maybe 6 months of several people's time just trying to plan ahead and scale these cluster self-managed databases. That basically went away after moving to DynamoDB. It was really quite magical to see them just dialing up and then after the event, dialing back down again. And this was the most recent number that we saw from Jeff Barr's blog talking about what DynamoDB handled purely for the internal retail teams around Prime Day. It's interesting to know. I mean, this sounds like a very impressive number. It's growing, continue to grow every year, but it actually only represents those internal retail teams. So it's worth understanding that that's just a fraction of the load that DynamoDB is handling every day, every second. So it's pretty amazing system to be a part of.
Yeah, and I take a lot of inspiration from the way DynamoDB works. I mean, the fact that in aggregate, the internal customers at Amazon were able to run over 100 million TPS without knowing all the internal details is quite powerful. And I think in terms of serverless services, Dynamo covers the essence of serverless the best. It's, you get better security, better availability, better scale. And one of my favorite things about Dynamo is that it actually scales to zero really well. And at the end of the day, it captures the core value prop. It helps people save a whole bunch of time by using Dynamo instead of building their own distributed clusters, which, as Pete mentioned, even teams at Amazon were doing before DynamoDB.
So I mentioned Alex a little earlier. I thought maybe we had Alex Debris joining. Alex is a super cool guy and someone I really love to talk with anytime I get the chance around DynamoDB modeling and just how the service works internally. He wrote a pretty phenomenal book, the DynamoDB book. And we're going to give away a copy of that book to someone who's on the call today. If you tweet or share on LinkedIn something that you learned today, something that was a new insight for you, please just tag us and we'll keep track of that. We'll reach out if you're the winner.
And a lot of the insights here are also captured in an awesome blog written by Alex Debris on how to think about DynamoDB costs. There's very few people who can articulate some of these key lessons the way Alex can, and he has written an awesome blog, and Kelsey's just shared that in the chat. And I just read from Aaron that Alex is in the audience. So if you are Alex, I didn't mean any of what I said. No need to blush. All right.
I don't think it's the real Alex.
Yeah, there.
Oh, yes, he
Oh,
is.
he is. Oh my goodness.
Yay. Hey, Alex. Good to see you.
All right. Alex is here. Cool. I'll try not to get too nervous since both Alex and Aaron are here. Quick trivia. So DynamoDB magic numbers, 4 kilobyte and 1 kilobyte. Why are these numbers magical? If anybody has ideas about what the meaning of these numbers is, please go ahead and chime in on the chat room. We want to make this as interactive as we possibly can. Daniel guessed 4 kilobyte max item size. That's close. I think the max item size is still 400 kilobytes. Although it gets a little tricky using DynamoDB with 400 kilobyte objects. We can, yes, RCU and WCU size. That's right, from Alex. So it is the read capacity unit and write capacity unit size. So when you read an object from DynamoDB, whether it's 1 byte or 4 kilobytes, you pay the same. You pay 1 read capacity unit. And for the same thing goes for writes. Whether you're writing a byte or an entire kilobyte, you pay the same thing. So your reads are rounded up to the closest 4 kilobyte boundary, and then your writes are rounded up to the closest 1 kilobyte boundary. And this is really important because it actually comes down to why you should really pay attention to item sizes for your cost. So if you go to the DynamoDB page, and we'll look at on demand for now, the ratios are pretty similar on the provision capacity and the reserve capacity as well. But a write capacity unit, you can pay $1.25 to write 1 million items into DynamoDB. Doesn't matter if they are 1 byte or 1 kilobyte. Now, if you're writing 2 kilobytes, it's, you know, $2.50 per million writes, because each write will incur 2 write capacity units. And you'll notice that the reads are 1/5 the price. Now, if you start to think about DynamoDB write pricing as dollars per gigabyte, the answer actually starts to vary based on your item size. So if you're writing a 1 kilobyte object, writing about a gigabyte, you're going to pay $1.25. 1 million 1 kilobyte items, it's about a gigabyte, and you pay $1.25. If your item size is 0.5 kilobyte, I just did some easy math there, the price per gigabyte actually doubles. It's $2.50 per gig. And if it's 250 bytes, it's $5 a gig. And if you're writing very tiny objects, your price per gigabyte to write it actually goes into $12.50. And we'll share some tips in a few minutes on how to avoid paying $12.50 for your 100 byte items. But let's keep going. So if you have a 4 kilobyte,
Khawaja,
yep.
Sorry to interrupt. There was a really good question in the chat I just wanted to address for everybody, and that was about making a write. When you make a write and just update one small attribute, the assessed size for write unit consumption is based on the overall size of the item, as if you were rewriting the entire thing. And the way that I look at that is actually it's based on the largest of the prior or the original or the new image. So on a delete, when you delete a 5 kilobyte item, that's going to cost you 5 write units.
Yeah, this starts to get in when people are doing things like modifying a counter inside a large item. You're just updating one value, but you're ending up paying for the entire item as well. And that's where larger and larger item sizes above 1 kilobyte start to kind of impact your costs a lot. And that's when true data modeling starts to come into play in terms of what you can do to avoid those surcharges. Good call out. So if you have, let's say, to keep things simple, a perfectly sized 4 kilobyte item, your writes are actually 20 times more expensive than reads, because for a quarter, you can read 1 million 4 kilobyte items. But each write will actually cost you 4 times as much, because writes are measured in 1 kilobyte increments, and then writes are 5 times as expensive. So it ends up being 20 times as expensive to write than it is to read. And Pete will always correct me anytime I bring this number out. So go ahead, Pete.
So the other part about this is that if you're making eventually consistent reads, you get a 50% discount on that. And so it's more like 40 times more expensive, actually.
So
Eventually consistent reads are the default.
And so we're going to focus on writes just because as engineers, if you're doing profiling and you see that so much of the cost is coming from your writes, we'll come to eventual consistency in a second, Alex. Good call out. But I promise we'll be there in less than 5 minutes. So if you have a 1 kilobyte item and you add a byte, now suddenly that is 2 times as expensive, because what you have done is you've crossed over the threshold of your write capacity unit. And now you need to spend an extra write capacity unit to write that 1.001 kilobyte of an object. So this is where things start to get very interesting, because oftentimes, as your items are getting bigger and bigger, as they cross over from just under that 1 kilobyte to over that 1 kilobyte, your write bill can actually double very quickly. And, so just going back to our old chart, 1 kilobyte items are roughly $1.25 a gig. 1 kilobyte plus 1 byte is roughly $2.50 per gig. So you can very quickly see why item sizes start to matter. And just like the Geico commercial, anybody back in the days where TV was popular, Geico's commercial always just say 15 minutes could save you 15% or more on your car insurance. Well, the DynamoDB version of that is 15 bytes could save you 50% of your DynamoDB bill. And let's go through a real life example of where 15 bytes could actually do it. Now, if you go to the, you can tweet that, Ben. If you go to the DynamoDB documentation, the official documentation, and there's awesome blogs on this kind of stuff as well, but the official documentation says you can store date and time as either a string or a numeric data type. And if you're going to use a string, follow the ISO 8601 standard, which is actually quite a good, standard to represent time and date. It covers time zone and things like that. But look at how long the ISO 8601 date looks like. It is a string. All those bytes exactly. That's a lot of bytes. That's 20 bytes in that string, from 4 digits for your year, 2 digits for your month, 2 digits for the date, the time zone, the hour, minute, second, Zulu at the end. That's a lot more than what you really need. And there's a big implication of whether you're using string or numeric data type. So if you use a numeric data type, that's only 8 bytes. And this 20 bytes turns into 8 bytes, saving you 12 bytes right then and there. And, one of the things that we introduced in DynamoDB was data types. So I like to play a game called Date a Dynamo Data Type. So there's a lot more than just string. It's always easy to just think about strings and just encode everything as a string. But these data types are actually really nice, where you don't just have string. With this came out with the release of JSON capabilities in DynamoDB, but there's all kinds of data types, including binary. So you can put compressed data inside of Dynamo as well and store it as a binary attribute. You can store bools. You can have maps, lists, and sets. Now those get kind of hairy, but there are data types that are much slimmer than others. And the other thing I learned, this is something that when I was transitioning over from relational to NoSQL, I never appreciated until I started paying attention to DynamoDB sizes. Now, because there is no schema, the name of each attribute is actually stored inside each item. So your choices on the name of the items can actually have a meaningful impact on your write capacity units and your read capacity units that are consumed. So things like calling timestamp versus TS. Now, you don't want to overdo the brevity thing. I get it. Like sometimes it could be more confusing, but if you're right over the edge, you might want to consider using shorter names in your for your attributes. And everybody has their
Perfect example here would be some kind of an IoT table, right? We were recording a temperature measurement. If you call that attribute environmental temperature, and then the temperature is just a tiny little number, 90% or 95% of your costs are all about that same attribute being recorded again and again and again. So this is really important.
And it has all kinds of, Ben asked if in the DynamoDB console, when it shows the item size, it does take that into account. Your attribute names, they go into, counting for your item size. And this has all kinds of implications. Not only is item sizes, can be used to reduce your cost, it can actually be meaningful in avoiding brownouts and throttles. So DynamoDB, a single item can be written about 1,000 times a second if that item is 1 kilobyte or less. If your item is suddenly 1 kilobyte and a byte, you can only update it 500 times a second. And it's not just the item level limit, it's the partition limit. So if each of your items get bigger and bigger, you're much more likely to run out of IOPS on your DynamoDB partition or on your table. So item sizes actually have a meaningful implication, not just on your cost, but also on your brownouts and throttle. There's another kind of way to look at it. I call, we try to put in a bunch of Simpsons codes here, but there's item sizes can make your DynamoDB items more aerodynamic. What does that mean? More aerodynamic means they flow through the network a little bit faster. Why is that? Well, imagine if you're doing a query or a scan, then your single result will actually fit more items into the response as well. So these types of like little changes, it's not just about saving 15 bytes just to go over the boundary, but just being meticulous about your item size. Dropping it from a kilobyte to 500 bytes can actually make a big difference in, your end-to-end performance, especially if you're paginating or if you're doing your scans and things like that as well. Anything to add there?
I like to think about this in terms of, traditionally people maybe had a DBA that managed the database for them, and they would often help you figure out schema and adjust things and add and remove indexes and take care of some of these things. In DynamoDB, you have pretty similar concerns, right? Smaller items are more efficient. Same thing in MySQL or Postgres. So these are things you need to think a little about during the data modeling journey.
Yeah. I'll let you continue on this one, Pete. This is your graph.
Aha. Here's the chart that I promised for David. Maybe not for exactly what he was looking for, but when you look at the pricing here for writing 100 gigabytes of data, and I've done this with on-demand capacity mode and pricing, the pattern is the same with provision, just maybe lower cost. But you can see that from 1 kilobyte on down, things get dramatically more expensive for like bulk ingestion. If you have 100 gigabytes of data you need to ingest, and it's made up of 50 byte items, it's going to cost a lot of write units. Closer to 1 kilobyte, you're going to be doing a lot better. Of course, the other way to look at it is, well, it's not so much that I'm looking at this as a total volume of data. It's I have 100,000 unique keys that I need to be able to work with separately, more of that online transactional processing thing. In this case, you just want to try and keep somewhere, small. You want the smaller, the better. So for things where you're doing updates, deletes, these kinds of changes, small is always best. And the sweet spot really winds up being just under 1 kilobyte. If you had a use case where you were doing something like ingesting a bunch of data, like the IoT devices, for example, you can do something we used to call, I don't know, Lee may still use this term, but item packing. where rather than just writing each individual item of 50 bytes each, because the overall 100 gigabytes is going to be expensive, you actually buffer this and try to write 10 of those items or 10 of those readings into a single item, for example. Gets a little bit more complicated, but this is a logarithmic scale. So making a change here between a 50 byte item size and a 950 byte item size dramatically changes your costs. Did I miss anything, Khawaja?
No, you didn't. I was just taking an opportunity to be punny on the chat. David has a great idea on the console where if the dates could be rendered appropriately. And Pete, you mentioned this to me last night that if you store the dates as numbers, you can also reuse the same attribute as your TTL value as well.
Absolutely, yeah. For TTL to work, it needs to be stored as a number in seconds since the epoch.
I think that's one still you.
Oh, me. Okay. So yeah, let's talk about the DynamoDB pricing model, the basics of it. DynamoDB has been around quite a while now, and I think they really did a good job in thinking about how to set the pricing model. There's a few little subtle nuances that we're talking about here, but the thing that I love about it is that it fits that serverless model so well, and it also tends to map to what the server side cost is to provide that or to answer that request. So the things that the elements that are involved in your DynamoDB pricing are the overall stored volume. And that's similar for things like backup and restore. It's all about the overall data size. And then there's the throughput, the reads and write units. And that's based on item size as stored, not necessarily as it goes over the wire, because DynamoDB uses HTTP, binary data gets base64 encoded and so forth. But as it's stored in the service, and as it's documented.
Oh, I think we lost Pete. But what he's basically talking about is that your item size choices will actually impact your overall storage as well. The important part, though, on the first bullet is that DynamoDB actually is quite generous. Even though your writes might take, even if you're writing 100 bytes, it costs you 1 kilobyte of writing. They actually only charge you for the actual amount stored. So items aren't rounded up at the storage side. So if you store 10 100 byte items, you're still going to charge for 1 kilobyte of storage instead of 10 kilobytes of storage because it's 10 different items. And that is quite a powerful thing, not only because your storage bill is lower, but it helps you grab more data quickly for your scans and for your queries as well. And this is basically his second bullet, which is, your throughputs and reads are based on the item sized as stored. The writes aren't based on item size as stored, but unless you're doing bulk ingest, which we'll get to in a second. And then read capacity units are, 4 kilobytes versus 1 kilobyte for writes, and you get a 50% discount for eventual consistency. Now, one of the really, really cool things with DynamoDB is that you can get a secondary index, but you got to be careful because a secondary index can actually, your first one can double your cost. If you're not careful, and if you just say, yep, project all my attributes, just know that, the choices that you're making in projecting all the attributes, especially if you don't need all of them on the secondary index, might actually cause you to double your index. Now, there are many cases in which this is worth it, and there are many cases in which it's not worth it. So be very mindful of when you're adding GSIs, think through what projections, whether you actually need the GSI. Because if you leave that GSI, idle, you're still paying for all the writes to it. And then whether it needs to be a sparse GSI or not, do you need to project all the attributes or not? And then, be very careful with redundant GSIs. So, Pete would have covered this, but each secondary index, you can think of it as a DynamoDB table. So back in when we learned programming, in C, C++, and world, like our professors taught us that an array is just a syntactic sugar. Right? There isn't really a thing behind the scenes that's an array. It's It's just syntactic sugar for doing pointer arithmetic on where to find the item. A GSI is basically another table. It's syntactic sugar for another table that the DynamoDB team maintains for you and make sure it's up to speed with a new index. And each GSI is essentially another table. So while I was very happy that now you're no longer limited to 5 GSIs, just be mindful that if you put 20 GSIs, you could actually meaningfully increase your costs as well. So be careful in which attributes you choose to project. Don't default to all. And then use sparse GSI when needed. And then if you're not using a GSI, just drop it. If you made a mistake, you can always use online indexing to add it back. Now,
So I have one thing that I wanted to add when I accidentally dropped off the network.
Yeah.
When you mentioned that adding a GSI could actually double your write costs. One of the things that's a subtlety about GSIs is if you are changing, your GSI is keyed on some attributes that are not the key in the table. If you change them in the base table item, you just change a number or increment a counter, and that's a key for the item in the GSI. In the GSI, to project that, DynamoDB first has to delete the original and insert the replacement because the key has changed. And so it can actually be worse than doubling, depending on what you've chosen for your keys.
Oh, that is a really good point. Yeah, the key.
I wanted to slip one in before I drop off the network again.
Yeah. All right, so we'll keep going. Now, one of the items that Alex Debris mentions on his blog that Kelsey shared earlier is that on-demand is 6.94 times as expensive as provision capacity. Now, does that mean that you shouldn't use on-demand? No. I think there are many cases and many teams in my experience that have actually benefited from doing on-demand. Now, provision capacity can be 7 times roughly more expensive, but there's a few tricks that can make provision capacity actually easier to manage. So if you think about your provision capacity being 1/7 the cost of on-demand, the reason why it's worth it is it really depends on your utilization. If you're utilizing more than 15% of those IOPS, you're better off just using provision capacity. So if you provision 100, but at any given time, you're, on average, you're consuming 15, you're going to be, fine. But that's a lot of management, right? Like you have to make sure that your utilization is actually at 15%. That becomes really hard if you have a high peak to average ratio or if you have really spiky traffic. So in many cases, if you've got that spiky traffic, with sudden bursts and so forth, on-demand might actually be cheaper. Now, if you don't have a spiky traffic and you have a pretty consistent or let's say a diurnal pattern where you only get busy from 9 a.m. to 10 a.m., you can plan around it. You can have auto-scaling rules that can be scheduled so that you can provision capacity for during the periods of the day where you are busy and then deprovision it when you're not busy. If you're willing to do that overhead, you can actually meaningfully increase your utilization and making provision capacity even cheaper. And then a little known secret that is no longer as obvious as it used to be is that you can get 90% off your provision capacity by signing a 3-year commit with DynamoDB. So at that point, so what you can do is you can have a subset of that provision capacity be reserved. So then it's really, really cheap. And then, your spikes can be paid at the, when you provision up and down at what I used to call on-demand rate, but it's now I think that term is overloaded. But, you can pay the market rate for your provision capacity that's above a certain spike, reserve your minimum threshold to get that, steep discount. And, playing tricks like that can actually meaningfully help you reduce your DynamoDB cost as well. There are more tricks that you can use. So, instead of mining Bitcoins, you can mine IOPS. And there are a few tricks that you can use to get Dynamo to give you free IOPS. A delete in Dynamo costs as much as writing that item. So if you delete a 1 kilobyte item, it's basically uses up a write capacity unit. But if you use TTLs, the deletes happen for free. So if you can tolerate a little bit of a delay in the deletions and so forth, and if you can tolerate the dynamics of DynamoDB TTL, and you really want to save money, you can let DynamoDB erase it for you based on TTL policies. And same thing for online indexing. So if you are doing, let's say, a bulk ingest process, you've just got some data that you're just loading into DynamoDB for temporary reasons or whatever, you don't have to have indexing turned on from the beginning. You can actually just let Dynamo, fill up your table and then create the GSI, and it'll take a little bit longer, but then you get all those IOPS for free. And then same thing, if you just drop a table, it's a very scary thing. So be careful before you go drop in tables. But dropping a table allows you to delete a lot of rows or a lot of items without actually paying for those IOPS either. So if you model your things appropriately, you can get a whole lot of bulk deletes out of the way by just dropping entire tables. And that is as Pete likes to call it, it's a free control plane operation unless you drop a production table that you didn't intend to. So be very careful with tables. Now, other sneaky ways to mine some IOPS. Bulk data import from S3 is much, much cheaper than writing the individual items. This is especially true. We mentioned earlier, if you have, a 100 byte item that you're writing, you're paying 10x the capacity to write. Imports, I think, are like 15 cents a gigabyte. And it doesn't matter like what the individual item sizes are. And that's a pretty major savings if you're, if you've got a bunch of data, rather than writing your own code to parse it and bring it in, you can just pay DynamoDB 15 cents a gig to import and 10 cents a gig, I believe, to export the data to S3. And now they even have incremental data export. So this makes life a lot cheaper compared to doing scans and queries on your data. So like this bulk export feature in DynamoDB is quite powerful. And if you're doing things like analytics on your DynamoDB tables, just use the export. It's quite nice. Now, today I posted on Twitter that I'm going to be, giving this live webinar with the famous Pete Naylor. And he said, well, famous or infamous, we'll find out. And he reminded me of one of my favorite Simpsons episodes where Dr. Nick sets an oxygen tank on fire because he says, wait, inflammable means flammable? What a country. Now, we'll do a quick trivia. What can I possibly be talking about? What in Dynamo could be akin to inflammable means flammable? Any guesses? Ooh. You already know the answer. Oh, single table design. That's
a little inflammatory.
We'll do a dedicated session on that one day. I'll distract Alex Debris and Pete can have that session. But yeah, so we're not going to dive into STDs here, but flammable. DynamoDB strongly consistent reads can actually be stale. And it is really, really important to internalize this because strongly consistent reads cost you twice as much. And they don't actually give you much more freshness than you might think. And Kelsey can put in like she just put in a tweet that I did on this topic. But essentially, how does consistency work in DynamoDB? You've got a primary node and the node has 2 replicas usually. And when you issue a read, it can go to the primary, in which case you will get the freshest data. So you have a 33% chance of landing on the primary because your request is being handled pretty randomly there, and 66% chance of a replica responding. Now, almost all the time, the replicas are pretty damn up to date. In fact, by the time, usually when you insert something, by the time you hear that it's inserted, all the replicas usually have it. And so for the most part, you can't rely on this, but for the most part, your eventually consistent reads in Dynamo are actually pretty fresh. The fallacy here is that strongly consistent reads are not as consistent as people think. So what could happen is I issue a consistent read. Before that consistent read makes it back to me, and I parse the response, and then I act on it, somebody could have modified that item behind the scenes. So while the response was in transit, that item could have actually been modified. It's actually worse than that. That item could actually be modified before the response even leaves the DynamoDB storage node. So because, while Dynamo is writing the response on your strongly consistent read from the primary, while that's being written to the wire, some other thread can be updating the item. So you got to be very, very careful with why you're doing a strongly consistent read. And there's very few cases in which it actually makes sense.
So you know how many times I dug into this and tried to explain it with AWS teams, Amazon teams, external customers while I was a specialist SA. I'm sure Lee gets this all the time too. But when you make that strongly consistent read, it's not a lock. It's not guaranteeing that by the time you get that response, it will still be that value. All it is telling you that any writes that you made in that same thread prior to making that read will be reflected. Other writes might also be added on afterwards in the response that you get. So you're not really gaining as much as you think you might be. And in fact, if your intention is to be able to write something, maybe you're incrementing a counter or you're adding $5 to a total. If you want to get back what the resulting view of that item is after you just made the write, you can do that within the write. There's an option, a parameter that says, hey, return me the latest view right as it looks after I complete this write, after it's written, if it's meets the condition. So strongly consistent reads actually very rarely make sense. And I will tell you that I feel like 90% of the developers that I worked with went with strongly consistent because it sounded safer. And it's actually slower, less available, and more expensive.
You're more likely to get throttled. And it's a very, very dangerous security blanket because you think that you're getting more fresh data, or your expectations are off, because most people, when they're doing a strongly consistent read, their assumptions on the level of freshness is they're overhyping to themselves how fresh this data is going to be. And because it's a strongly consistent read, it can only come from the primary node. So it has to come from, so you don't have the IOPS available on the other nodes. Yeah, slower, less available, and more expensive. Sign me up. Alex, that's a great insight. Maybe you'll win the raffle for the Alex DeVries book. But but no, like it's really important. And I have fallen for this myself. So there are other tools that are available to you that are actually much more profound if you're trying to establish causality or condition. So if you're thinking of using a strongly consistent read, you probably want to just do a conditional update. And one other, like a little bit deeper anti-pattern that I fell for once was I was doing a strongly consistent read followed by a conditional update to improve the odds of my conditional update getting through. And this is a fallacy. Like even in this particular case, I'm better off doing an eventually consistent read. And the reason is that the only way I'm going to benefit from doing a strongly consistent read is if there was a lot of churn on that item while I was reading it and then writing it. And if there's a lot of churn on that item while I'm reading and writing, man, conditional updates are probably going to struggle anyway. So anytime you find yourself reaching for that strongly consistent read, even if it's like right before you do a conditional put, most likely just ask yourself, can I just pay half the price here and use an eventually consistent read to get better availability, better performance, and better throughput? And yeah, so save your dollars unless you actually need it, and then read that thread to kind of determine whether you really need it or not.
All right, I think this must be one of my slides. It's a bunch of text and no really cool graphics, but
it's more insightful. That's how we know it's yours.
Hey, did you notice that my internet kept dropping right when it was my slides? Sorry, Khawaja. But so because I went through this so often with customers in DynamoDB, just guiding through them through the process of how do I cost optimize for DynamoDB. There's kind of a prioritized list that you should go through. The first thing, and the thing that can make the biggest impact, is your data model. Getting those item sizes right where they ought to be, making sure you're doing things efficiently. I've seen a data model review literally reduce cost by a factor of 10 or more very easily. Of course, you want to do this up front if you can, rather than having to change it later. But that's the first place, the first thing you need to look at. You want to minimize that projection for your secondary indexes, because the write costs associated with propagating change into the index can be very high. If you're projecting an entire 100 kilobyte view of a large item, you really don't need all of that data. Maybe all you need is 3 or 4 attributes. Only project those. It's going to save you a lot of money, and it's going to scale a lot better. Get rid of those unnecessary secondary indexes. I see this all the time, going through the console, looking at things, and you just go look at those indexes and realize that there's actually no read traffic on them. So someone created them long ago, thought they were going to need them, never actually did code them into the application, and now they're just sitting there. So get rid of them. Operationally also, you don't want to leave them sitting around. Sometimes you make a change and forget that index is there, and suddenly you create a hotkey situation without even thinking about it. Disable those consistent reads where you really cannot justify them. They just don't make sense for most of the places that people say they need them. Shift the low throughput and sporadic use tables to on demand. I would work with customers who have of tables and they want to go through this, and I say, look, what's your time worth? If you have these tables that are only occasionally used, dev tables, these kinds of things, or they're very low throughput, such that in on demand their cost might be, I don't know, set your own level, right? $20 a month. First thing you can do is take a pass through there and switch all of those to on demand, get your time back, and then think about maybe spending some more time on the high throughput tables. Trying to save by making a provision capacity work, adjusting auto scaling. And by the way, there's a lot you can do to improve your utilization in your auto scaling policy. For example, on reads, you could try caching, right? That's gonna smooth everything out, and you're not going to be building in extra capacity to cope just with spikes. The cache will take care of that. On writes, if it isn't like real-time writes, if it's something where you're just ingesting, like that IoT use case, you can do queue-based load leveling, so that things don't spike so much. And now your utilization can be much, much better and provisioned. And then finally, look at reserved capacity. I know there's a lot of folks that just kind of shy away from that because it's a 1 year or a 3 year commitment. But if you're going to be using DynamoDB for a year and you don't expect to be drastically reducing your usage, at least start with your auto scaling minimums, add that up and buy that much reserved capacity. And that's about all I had. I think once you run through all of that stuff, you're probably going to be pretty pleased with the change that you see in your DynamoDB bill. We did keep these slides. Go ahead. You want this one?
Oh, this is your slide.
Okay. Well, so the other thing that I wanted to talk about is using the right tool for the right job. I talked about this a lot just in context of DynamoDB and other AWS databases when I was a DynamoDB SA. You really have this range of options, right? I've seen people using S3 for something that probably would have been cheaper and better in DynamoDB. I've seen it the other way around. Now there's serverless caching. Think about what you need in terms of durability. What are the things that you really, truly need to have? If you don't need the durability of DynamoDB or S3, maybe you can do something cheaper and maybe faster too. There's a lot of different options. And I think to some extent, there's been a lot of draw to using these serverless services purely because they're just so much nicer to use, right? There's a lot of reason to want to stay with something serverless and offload all of that ops. But you know, if you're then stuck with just using DynamoDB or S3, those have particular strengths, and maybe your use case isn't really the right fit for that. So really think through, is this the right store to begin with? Where you want DynamoDB is where you want atomicity, consistency, isolation, and durability, that ACID compliance you want from an OLTP database, where you want to never, ever lose a write, for example. And you're working with per item, right? Consistency there. Oh, these are OLTP type loads. They're not really great for analytics. DynamoDB's strength is in small and simple items, by the way. If you know, not just the size of the item, but if they're extremely complex, that can affect your latency as well. You're going to be using known query patterns. These are things like supporting your UI, a console or something like that, where there's limited filtering over the scanned data. It's fully indexed. There's no server-side compute requirement. You know, when you use a relational database, you get a ton of power there, but it actually uses a lot of the compute on the server side, and that affects latency. So they each have their strengths. Make sure you're using the right tool for the job. DynamoDB is awesome for any scale. I know when I first started working with DynamoDB, we would often talk about it as, you know, being great for immense scale. But the reality is it's phenomenal for tiny workloads too. If you're using on-demand and you're only making 5 reads a month, that's a great way to go. A lot of other services, even the ones that call themselves serverless, have a minimum buy-in where you're essentially going to provision a certain amount, and that might even be $500 a month. You only need those 5 reads a month. So it doesn't make sense. DynamoDB is fabulous for these types of use cases, and I still love it. And this is the table I talked to David about. I know it's kind of an eye chart on here, a lot of tiny stuff, but it really breaks out where to use which kinds of store. I can share this, and I think we can share the slides as well if anybody wants to keep this. But it was really helpful actually for me to sit down and just write down, you know, what are the things that really characterize these different types of stores and when you want to use them.
Let's see. I think we have a couple of more slides, but I wanted, like, if it's okay with you, Pete, I wanted to see if there's questions people have, or we can cover those other slides too.
Any more questions from folks? I see there's a fair bit of chat going on here, which is cool.
Yeah, we were making fun of the number of characters in your slides and how that's expensive on the network.
Oh, brutal.
There's a GSI question from Alex Mitchell.
Yeah, so let's imagine in your base table, you have an item which has a date, and you're going to periodically update that date entry. If you're using that date as part of the key for the GSI, when you change essentially the primary key, DynamoDB has to get rid of the original item. It actually deletes it and then reinserts the updated item with the new key within the GSI. And so, you know, if you've got a less than 1 kilobyte item in your base table that's being projected into your GSI, a single change of just a few bytes in that base table will result in 1 write unit there and 2 write units to propagate to the GSI. So suddenly you go from 1 to 3.
Okay, one more. Oh, I like this question. I can tell you what my not favorite way is, but I'll let Pete answer a more insightful way.
You know, I know there's a number of tools out there. I've looked at a few of them. I spend a lot of time with Nosql Workbench just because I was at AWS and I wanted to dog through that and be able to give feedback to the team. I really like to just sit down. In fact, when I was doing design reviews with the AWS teams that were building on DynamoDB, I'd ask them to come to the session with a list of their access patterns and Also maybe a mapping of items and how they're related. One thing that I saw a lot was, if it's a new build, a new solution, they would say, well, we don't know what all our access patterns are. We have to think about that. And so I would say, if you can sit down and write me a list of your different APIs that you're going to expose, we can look at those and figure out what the access patterns will be behind them. So people like to say they don't know just because they're worried that some others might be added. But I don't accept that. I think it's actually pretty easy to sit down and think about what those patterns are. And with DynamoDB, there is some flexibility to add support for different patterns later, right? You can add additional GSIs. You can add different attributes because of the flexible schema. It's really more flexible than most people realize. In the worst case scenario, you have to rewrite your data, but that can be solved also.
All right.
One of the things I love about NoSQL Workbench was I would sit in the session and just model something up really quickly, and you can see what's happening with the projection and the GSIs and the sparseness and so forth. Then I would save that out. I would send it to that team, and they could then load it up and look at it themselves as the design is evolving. And ultimately, you can then get screenshots and things like that to add into your documentation. So that's a pretty useful approach, in my opinion.
Oh, are there benefits to using the batch write? I'll answer the write and then the read question. The batch write API, I don't find it to be more efficient, especially just because I'm familiar with the way it's built. You don't get any cost benefits of doing a batch write versus like 25 batch writes in one request versus 25 individual requests. The 25 individual requests might actually succeed faster. So I like doing individual requests for fanouts. If I really need to do a big bulk ingest, I will just do an S3 data import. And then for reads, unless it's a query, you get, like, if it's a query and you're reading multiple items, you get the savings, because if you read, 4 contiguous items that are 1 kilobyte each, that's 4 kilobytes. It only cost 1 read capacity unit. But if there's like 4 individual items with completely different keys, you are going to pay 4 different RCUs on that. Then Alex asked if it fails, it's how many WCUs. I believe it's the number of WCUs that you spend on it is the size of the item. So if the item is, 1 kilobyte, you pay 1 WCU, even if it fails. If the item is, let's say, 400 kilobytes, you pay 400 WCUs. And
yeah, there's a subtlety here. And it's, for me, if you have an item that's 300 kilobytes and the condition fails, you're actually assessed write units, even though no write was made, nothing was replicated. And it's based on the old image size. So 300 kilobytes, that would be 300 write units, just to say, nope, the condition wasn't met, nothing was written, which to me is a little unfortunate, because it's this conditional write aspect that DynamoDB supports so efficiently and so well, because it has a strong leader-based replication, is a really strong benefit to using DynamoDB. And I feel like for people wanting to use it, it looks like a little bit of a penalty, but that's how it works.
yeah, and Alex has lobbied for this many times, and it seems like Ryan is lobbying for it as well. I think there's a few Amazonians in here who can take this request to the DynamoDB team. I can tell you, this isn't intentional or nefarious at all. Like, there's trade-offs, right? Like, these types of dimensionalities just make the pricing much more complicated as well. So there's this notion of like keeping the pricing simple, and you can imagine, like, DynamoDB pricing is not really simple to wrap your arms around to begin with, and like adding more dimensionalities and more conditions on pricing can make it more complicated, which, at least in my opinion, is why it's priced the way it is, because this is not a new artifact. It's always been there. And
Anybody, so a trick question here, is anybody know of one of the DynamoDB write APIs that will actually return or consume some read units under particular circumstances? Alex knows this. Or if he doesn't, he's forgotten that I told him about it. There you go. Leo knew. Awesome. Very good. Item potency topic again. That's a really good one.
yeah, so I I wasn't picking on Dynamo. Come on, I love Dynamo. You know, but the really enjoyed this conversation. Thank you so much for coming. The questions and the engagement on the chat was amazing. Just reminding everybody, we are going to do this for APAC again, and we'll record that. Kelsey, I think that's on the books already, right?
Yep, I'll drop the link in the chat right now.
So if you ended up joining us from APJ, sorry to keep you awake at an odd time, but we will do one for your friends in the APJ friendly time zone as well. And yes, we will record, we'll upload the recordings, Victor, as well. Right.
All right.
Thank you again, folks.
Thanks, Khawaja and Pete. I'll add the recording to our YouTube video today and send everyone a message.
Yeah, and if you don't mind, tweet about it, and we'll see you next time. We'll do more of these sessions.
Yeah, don't forget to do to share what you the best insight you got today. That way you can win a copy of Alex's book, maybe.
That's right. All right. Thanks, everybody.
Bye all.